Hello guys, welcome to another video. Here in this video I'm going to explain very basic strategies about how we can deal with a physics paper 1. Here there are a couple of things that we should do in order to make our life easier, strategies that we're going to use in order to solve problems, and you will see that it's something very specific that we have to do every time. Now first of all, we're going to go through the paper. Here you see that I have an exam paper from 2010 for standard levels. What you need to know here is that your total time is 45 minutes, it says. So that means that we have 30 questions in standard level. Okay, in the HL level, you have an hour to complete it, but you have 45 questions. Now, having 45 minutes and you have 30 questions in order to complete the exam, that means that you have 1.5 minutes for each question. So here I suggest that you spend 1 to 2 minutes for each question. Now some of them, they're gonna take you, I don't know, like 5 seconds or maybe 10 seconds just to read the question, because it's very easy just to pick the correct answer based on the definition or something. Now other ones though, they're gonna make your life very, very difficult. Now what we need to do with this, you see that you can spend more time, you can spend a lot of time in one question, and you cannot find something like a result that you like, then you just skip the question. Okay, don't spend 5 minutes in every question or something like that. Skip the questions and in the end, go back and try again. Now in the case that you will not be able to solve a couple of them for any reasons, for example, you will miss the question 14, the question 17, the question 20 and 25. So you have no idea what's going on here. What you have to do, you have to give an answer, whatever it is. You're gonna just try your luck here. But you will not choose for this one A, for the other one C, for the other one B, for the other one D or whatever. Okay, it's best if you choose all of them A, all of them B. And this is based on statistics, okay? You're gonna have more luck, better chances to get some of them correct if you just choose like this. Of course, you gamble here, so I will not suggest something like that, but just in case that you will not be able to solve, just give an answer. Here also you see instructions in the beginning, so in the end, later on they include more, like data booklet, it's required, and total marks are 30, but you don't care about this. The calculator is not allowed in your paper 1, but your data booklet is allowed. And here, during the exam, you don't pick up the questions, the answers for your questions in this paper, in the next page that you see all the questions, but you use another sheet here that you're gonna answer every question here. So the number 1 is gonna be A, the number 2 is gonna be D, and so on, whatever you are going to choose. Okay, so this paper is going to be provided to you during the exam. Now, after this, we're going to go through this paper, we're going to solve particular exercises, and it's going to be some of them only because they have this specific way of solving the exercises. Okay, so let's start here. I'm going to solve in general a couple of them also just for practice. Here in the first question, for example, it says, the best estimate for the time it takes light to cross the nucleus of the hydrogen atom is, and it gives you these options. Now, wherever you see this word estimate, you know that you don't have to deal with specific calculations. So what you need to do here, you need to say that speed of light, constant speed, so the speed is equal with the distance over time. And now what you have to remember in this case is that the distance that the light is going to cross, it's going to be the nucleus. So the nucleus, it has a radius of 10 to the power of negative 15. It doesn't matter if it's hydrogen or anything else, this is going to be the order of magnitude. And this is what you care about. I told you, you don't have to do specific calculations. And for the time is the one that you're looking for. Okay, and here you have also the velocity, but the speed actually, it's the speed of light. The speed of light, you know that it's 10 to the power of 8. You don't have to care about this 3 in front. So what you're going to do here, you're going to rearrange. So for time, 10 to the power of negative 15 divided by 10 to the power of 8. And from here, you are going to do 10 to the power of negative 15 times 10 to the power of negative 8. You're going to bring the denominator up here. If you do the math here, of course, pretty simple, negative 15, negative 8, it's going to be 10 to the power of negative 23. So your answer here is going to be A. Now, some people, including me sometimes, because we try to do it fast, we see here, negative 15 plus 8. So you do the math here and you find a number of 10 to the power of negative 7. And you see the option here, of course it's going to be an option here, in order like to confuse us, and we go here and choose D. But this, of course, it's not the correct math that we need to do. We need to be careful for our calculations. I know that we need to be in a hurry, but most important, it's for us to make it correct. I'm going to show you here another example. So let's do the number 3 that includes also calculations. So here it says, the time taken for a stone dropped from rest to fall vertically through 16 meters is 2 seconds. Based on that, estimate, again we see the word estimate, the acceleration of free fall. Here it's also important that we underline the key words. Here, from rest, it's something that it's going to help us. Of course, here we need to use one of the kinematic equations. So I'm going to use the equation number 2 because I'm trying to find acceleration and I have distance and time. So it's going to be u times t plus 1 over 2 at squared. This word from rest, it gives me that this one must be 0. So from here I'm solving for acceleration. So I have 2 times the distance divided by the time squared. Now, of course, you have every number here. You do the math really quick. In your mind also, you don't have to use calculator. It's not allowed anyway. So from here, you're going to find the acceleration to be 8. Of course, meters per second square. I'm skipping the units just for the time. So here you see that your answer is B. Now, another problem here that we might face is that estimate the acceleration of free fall. And of course, everybody knows that the acceleration of free fall, the average one, it's 9.8. So you can say like, okay, this is what I have to do, so it's going to give me this number. Well, this is not the case. You have to do the calculations in order to be sure which one is the correct answer. Now let's see number 5. It says, which of the following is a correct statement of Newton's second law of motion? When we talk about Newton's second law, we know 2 formulas that we can apply. Force is mass times the acceleration, and also force is the change of momentum over the change of time, so it's the rate of momentum. Also, here it's not just force, it's the net external force. So what we're looking for, it's going to be based on these 2 equations. If you see the choices here that you have one that it says a force acting on a body is proportional to the mass, so it relates to the mass, here the second equation. A force acting on a body is proportional to the acceleration, so it relates here with acceleration. So seeing that, also we need to pay attention on the phrase, how they express what they want. Here they say a force acting on an object. Which force? Any kind of force? No, here we need a net external force, so it cannot be. Also these ones, they apply when you have constant acceleration for the first one, or you have constant mass for the last one. So these phrases are a little bit incomplete. So we need to skip those. So we go next to the other 2 choices that we have. It talks about momentum here and here. Let's see the number C. It says the momentum of a body is proportional to the external force. Here it says the momentum. In this formula, we see the change of momentum. But for us, here it's not the case. Okay, so we have only the rate of change of momentum that is equal to the external force, and of course this is the correct answer that we need to apply. Now let's see the other one. Let's see the number 7. Now here it's one of the most important, not important, but the questions that you're going to see very, very often. So it says, 2 objects are undergoing inelastic collision. So here it's the key word. Which one of the following is correct in respect of both conservation of momentum and conservation of total energy? So when you see this kind of questions, you need first to check the one list and then the next one. So doing that, it's gonna reduce the number of choices to half at least. Because you see, momentum, you have 2 options, conserved, conserved, and you have another option, not conserved, not conserved. So if you know what is happening in the momentum, you can exclude the other cases. So you know that in any kind of collision, the momentum is conserved. So here cannot be D or C. And now you play only with the A and B. Of course, here in the total energy, it's going to be the two other options that you have. Here again, you have two options, not conserved, not conserved, and the second, conserved and conserved. But of course, it's going to give you the two different ones. And here we need to see what is happening to the energy. When we talk about total energy, then we know that it needs to be conserved. Be careful here because many students, they go and answer it's not conserved because they think about kinetic energy in an inelastic collision. But this is not our case. Here, the total energy. So this is why it's important to read the questions very carefully. So here, of course, it gives you the answer B. Now let's see the number 8. You have a particle P that is moving with a constant speed in a circle. Which diagram shows the velocity and the acceleration of the particle? Well, you know here that you have two options. First to look the velocity and then to look the acceleration. Now if you do that, you know that the velocity, it always needs to be tangent to the circle. So here you have to go and see which case it gives you a tangent velocity. It's the case C and the case D. Okay, so you have only these two options. You exclude the other ones. And then you look the acceleration. The acceleration in a circular motion, you know that is the centripetal acceleration. It's always towards the center of the circle. So out of those, which one can be? Of course, number C. Now, if you start looking first the acceleration, then of course, you have only one option. It's number C. This it can save you a couple of seconds, but again, it's not so important for us. Here, you have to look both of the situations. Now, let's go to this one, the number 10. So this is a tricky one. We have a definition. We need to define mole. And here you can see again that we have two options. We have the mass, here and here, and we have also the amount of a substance, here and here. So it can be one of those. Now, when we talk about mole, this is a definition that you have to know. You go to your book, page 102, and it gives you the correct answer to be number B. Because we talk about the amount of particles, it needs to be the same as the particles in 12 grams of carbon-12, and not the nucleus, the nuclei number. So here is the correct one. Now, why it can be tricky, as I said before? Because you might seen this exercise many times before. When we talk about mass, we define atomic mass. So if you change this word, instead of mole, say here atomic mass, then it needs to be A. But for us, we might have seen this exercise many times, and when I see only this image, I know straight away, oh, this must be an A. So I answer A, and of course, I get it wrong. So we have to be careful of what we read. Now, let's see another similar one, tricky again, the number 12. So what you have here? Here you have a graph that it shows the velocity of an object that undergoes simple harmonic motion. And then it asks which graph represents the total energy. Anytime that you see this total in front of energy, then you know that you talk about the total energy of the system, and this needs to be constant during the whole motion. So you have only one choice here. It's number C. Now again, sometimes this can be calculate the kinetic energy, or you have seen this before. And you know here that you have 3 points that velocity is 0, so the energy needs to be 0 at 3 points, of course. So you go here and you say the correct answer, it's B. But no, this is not the case. We don't talk about kinetic energy. If it was kinetic energy, then yes. Again, another example that we have to be very careful on what we read. Now, number 17. This is another problem that we're going to face many times. And this is usually a comparison between two different situations. So what we have here, we have a resistor of resistance 12 ohm is connected in series. This is the key word for us, with a cell. Of course, like internal resistance, it's insignificant, so we don't have to care about it. The power dissipated is P in the first situation. Now the resistor is replaced with a resistance of 3 ohms. What is going to be the new power dissipated here? So here, this is my case. I have a cell, it's connected with a resistor in series. So this is what I have. From here I see, because it's connected in series, that the potential difference in the resistor is going to be the same, even if I change that. So the only formula that I can work is for power dissipated, it's the V square over R. So I see my first situation, when I have a resistor of 12 ohms, the power is gonna be V square divided by 12 ohms. And then what I do, I change that. So I take the new resistor, that's gonna give me new power dissipated, that's called P prime, is gonna be equal with a V square divided by 3 now. So now what we need to do in order to do the comparison between P and P prime, we need somehow to create whatever we see here in my new equation. And then I will see the relationship between P prime and P. So from here, the easiest way to do it is of course to multiply both the numerator and numerator with 12. So here you see that I have created what I wanted. Here is the power that I had before. And then I play with the numbers, 12 divided by 3 is gonna be 4 times V square over 12. And you see here that V square over 12 is the power that you had before. So it's 4 times P. And of course, it gives you the answer D. The next one, let's do the number 23 here. You see again these boxes, so again it will give you two different options as you can see here. Neutrons only, both protons and neutrons, both protons and neutrons. Here as well. So you're gonna start working with one list. Let's work with this one first, and then we'll see what is happening to the next one. So it says, which of the following is true in respect of the Coulomb and the the Coulomb interaction and the strong interaction between nucleons in an atom. Whichever you are more secure of what it is, you work with it. Okay, I'm gonna work here with the strong interaction. Let's say that I know better about this. So I know that the strong interaction, it's always between every particle in the nucleus. So it's gonna be both protons, both neutrons. So it gives me only these two options. And now you look at the Coulomb one. The Coulomb one, of course, you know that it's between the charged particles, so neutrons are not charged, so it cannot be this one, so it's protons, so your answer, it will be number C. Let's see here a similar one, number 27. You have which of the following correctly describes the role of the moderator and the control rods in a nuclear reactor. Again, here I'm gonna choose to work with one, and then I'm gonna move to the next one. Let's say that I feel more secure about the control rods, and I know out of my options, the two options that I have, that the control rods, they control the rate of fission. That's why they call control rods. And now I move to the moderator. The moderator, I know that it slows down the neutrons. So my only option, it can be number A here. Let's see one more. Here, number 28. It's exactly the same as before. We have two different lists that we have to work. I'm gonna work in one first, and then I'm gonna move to the other one. So it says, which one of the following correctly shows the energy change in a photovoltaic cell and in a solar heating panel? And here you see that I don't have two options. I have three options. I have solar to thermal, and then I have two more. Of course, I know here for the solar heating, as the word it describes, solar and heating, it's from solar to thermal energy. Of course, it will give me these two options in order to make my life more difficult, but it's nothing difficult here. And then I'm going to photovoltaic cell. I know that it's solar and electrical, so it can be, and it's the only option that I have, it can be number A. So that's all. This is how we work in the first paper in order to save time and try to figure out the easiest ways in order to solve problems. Study hard and good luck.